Well, hey everyone. Thank you for showing up. This is a good turnout. All right. So my name's Colin Sullivan. I'm product manager at NATS, and we'll give you a quick introduction to NATS today. So first, let's talk about messaging. What is messaging? Wikipedia defines messaging as message-oriented middleware, which is what NATS is. It's software, hardware, infrastructure supporting the sending and receiving of messages between distributed systems. I kind of like Ken Klingenstein's description. Middleware is the intersection of the stuff that network engineers don't want to do with the stuff application developers don't want to do. We don't mention this when we're interviewing. So why does CNCF need messaging? As cloud technology has matured, distributed systems architecture has been disrupted via decomposition. We've moved from these large monolithic applications to microservices spread out all over the place. And communications has lagged a bit. Technology is needed to address some use cases. We need multiple messaging patterns bundled into one technology. Location transparency. I shouldn't have to know exactly where everything is to connect to it. The decoupling of data producers and consumers, and built-in load balancing. NATS was created specifically to meet these needs for the next generation of cloud-native applications. Now, what is NATS? NATS is a 7-year-old production-proven cloud-native messaging system made for developers and operators who just want to do their jobs. People who don't want to worry about messaging, just want something simple that works. The DNA of NATS, what makes NATS up, what's behind it is performance, simplicity, security, and availability. NATS was built from the ground up to be cloud-native. And we have common message pattern support, including request reply, publish subscribe, and load balance queue subscribers. So how did NATS come about? NATS was created by Derek Collison. Derek's been building messaging systems upwards of 25 years. He started at Tibco, where he was a chief architect, developing a lot of the messaging systems there. He was a technical director at Google. He architected Cloud Foundry, CTO and chief architect at VMware, and formerly at Apcera, which was container-based technology. And now he's founder and CEO at Synadia, where we maintain NATS. And we do have a very engaged user community, quite a few contributions, a very healthy Slack community too. So an overview. NATS is pure publish subscribe, and based on this, we build common message patterns on top. We support a clustering of servers with built-in auto-discovery. We've got clients for over 30 programming languages, log-based streaming to guaranteed message delivery, and then we also have some CNCF integrations, a Prometheus NATS exporter for exporting NATS metrics into Prometheus, and a Kubernetes operator. NATS supports a range of technical use cases, general messaging in the cloud, microservices transport, control planes, service discovery. We're also found in IoT, mobile and big data, high fan-out messaging. I need to get one message out to many thousands of subscribers. Replacing or augmenting legacy messaging. As I said in the keynote, we're finding that many of our users, as they move from on-prem to the cloud, find that their legacy, old, do-it-yourself messaging technologies just don't fit the bill, and they find that NATS really helps them with it. We have many users and adopters. Two of my favorite use cases. So one user came and told me, and I don't know if I can say who they are, but they said, we cannot replace NATS unless we pull fuel rods. It's kind of like, geez, that's, don't want to lose too much sleep over that. But that's how reliable NATS is for our users. And the other use case I love is NATS on a cell phone. And when the cell phone vibrates too much, their application sends a message over NATS to the cloud that aggregates and listens for these. When too many vibrations happen in one spot, it's an early earthquake detection system. So it's NATS saving lives. I love that. It's called the circular world. So some contribution statistics. 200 contributors. We have 30 public repositories. About 25 million NATS server Docker Hub pulls. About 7 million NATS streaming server pulls. A healthy Slack community. And pretty good cadence of NATS releases, about 20 over the last, 6 years or 4 years, so about 5 a year. Now, before we go on, let's talk about messaging patterns in general. Whoops. So NATS has 3 built-in patterns. Publish, subscribe. So that's where you publish data to a subject, and a subject's just a string in NATS, so some identifier. Publish data to a subject where one to many subscribers will receive the data. This is a fan out. So I might have 1,000 subscribers listening to the same subject, and I send a message from a publisher to this, and it gets fanned out to your thousands of subscribers. We also have request reply. That's where you send a request message, and we still use underlying publish subscribe, but we use guaranteed unique subjects. So you send a request message on a unique subject with a unique reply, and that creates a logical one-on-one request reply. We also have load balance queue subscribers. So these are subscribers that are bundled together in a group, and they're all listening on the same subject, but the server will only send a message to one of these subscribers. And if you can start out with a group of 1, where that subscriber will receive every single message published to that subject. And then let's say you want to auto scale. All you do is add another subscriber. No additional configuration. This is the perfect cloud auto scaling situation. And then what happens is the server distributes the load of messages between that subscriber. And you can continue to scale up or down without any configuration changes. So let's talk about NATS DNA. Performance and scalability, simplicity, security, and availability are what make up NATS. A good way to think about things is NATS is just what you need and none of what you don't. We try to be very, very simple and easy to use. So let's talk about performance. Performance is a part of every single decision we make. Any PR we merge, we look for performance. We take a very, very careful analysis of the fast path. Is this going to require extra locking? Are there extra memory copies? Can I get by without locking? Or are there even system primitives that are more efficient? So we look at that, and we also design for scale. So anytime we start looking at an addition to the protocol, we think, all right, what happens if I multiply this by 1 million, by 10 million? That's how we think about NATS in scalability. And we found keeping NATS simple has worked extremely well. But just as important as how we do this and how we look at performance is what we haven't implemented. We try to minimize state in the core NATS server. So in core NATS, basic NATS, we don't provide any message guarantees. We provide at most once. It's up to the application to make sure the message gets there. Sounds a little fragile. I'll discuss that more in a bit. We don't support transactions, nor do we support message schemas. NATS is payload agnostic. Nor things like MQTT's last will and testament, or if you're familiar with JMS, message groups. These are all things people have asked for us, and I hate to say no, but it's not part of NATS. But what this yields is 18 million messages a second. With multiple streams, we've gotten up to around 80 million messages a second. So NATS can perform extremely well because of these core values we maintain. Let's talk about simplicity. We aim for ease of use from installation through operation. We have a single binary. It's a very small Docker image, spins up very quickly, no external dependencies. Our protocol itself is simple. It's text-based with just a handful of verbs that are used. We've got very easy to use, parse JSON, return for monitoring endpoints, and a very straightforward configuration. With such little configuration, clients only require a URL and credentials. And servers only really need, there's one configuration file that you don't even have to use, and a few command line parameters. So clustering is automatic. And how this works with simplicity is that you configure just a couple seed servers, and as you want to scale up your cluster, point them to these seed servers. And everything talks about everything else. Your cluster topology is shared, and you don't have to configure your cluster statically. You can grow or shrink as you need to. Supported clients are also notified of these cluster topology changes. So that means you don't have to configure your clients as to where every node in your NATS server cluster is. You just need 1 or 2. They learn about the rest. And there's a very straightforward and simple API. Here's an example Go program. You connect. We're going to be nice and defer a close. And then you publish. You publish a message. You publish it to a very simple topic or subject. And then since NATS is payload agnostic, I just pass a byte array of hello. And then I flush just to make sure that the message gets out before the application ends. And I want to check for errors. Here's a Java subscriber that will receive and print that message. I connect, passing a URL and a port. Optionally, I could include user credentials in there, or include user credentials in the connect call itself. And then I subscribe, give it a Lambda function, where it just prints out that it received a message. And that subscribe waits in another thread, and you just sit and wait for messages. That's how simple a simple NATS subscriber is. Let's talk a bit about security. NATS secures distributed systems through TLS, user or token-based authentication, and authorization. You can update these at any time through a configuration reload, so you don't have to take the NATS server down to change these. We have TLS support. So we support, it's simple configuration in the NATS server. We support bidirectional TLS with client-side certificates. Certificate authorities are supported. We default to the most secure ciphers, but you can override these and override curve preferences in case you're connecting with older legacy systems. Credentials with a username or password or token are associated with a connection. So when you connect, you pass your credentials. And any credentials we store, you can decrypt them so that operators reading a configuration file or operators that may have seen how the NATS server was started will never see the password. We have authorization with permission-based roles. All it boils down to is who can publish to what topics or subjects and who can subscribe to what subjects. And again, we have configuration reload where you can update, add, or remove TLS certificates, add or remove credentials, and grant or revoke permissions. The Synadia team, we're working on a new architecture, and look for this in several months, where no private keys or passwords will be stored on the system. And availability. Here's where NATS really differentiates itself from other messaging systems. So NATS prioritizes the health and availability of the system as a whole rather than trying to service one particular client. So we think of it as like a dial tone. NATS is always on. Anytime you go to connect, it's always on. But it achieves this through what I've called selfish optimization. So you have a badly behaving client, a slow consumer who's not keeping up. The server needs resources to handle that consumer, right? Well, what NATS does is it cuts the consumer off in the interest of keeping the system as a whole resilient. Other badly behaving clients, if you send garbage, NATS cuts you off right away. We also have full clustering of the NATS servers. And what this means is that no matter which server goes down, which pod you kill, there's going to be other ones that know about the system as a whole. And it's self-healing. If you bring up the pod that you took down, it'll automatically reconnect to the cluster. Clients also automatically reconnect to the servers they know in the cluster. So I spoke earlier about auto-discovery. So the resizing of a server cluster can be facilitated through auto-discovery. Like I said, you start with a few seed servers and then add servers. Topology changes are propagated throughout the cluster, allowing servers to join the full mesh. Supported clients are also aware of topology changes. Internal knowledge of the cluster topology is propagated to all the clients, and they can automatically fail over to new servers in the cluster. So that means as you add new servers to the cluster, clients can actually connect to new servers they never originally knew about. This is huge in cloud computing because, as you all know, pods come up and go down, images come up and go down. So this results in no configuration changes for clients when the cluster or topology changes. Some of our users really like the resilience of NATS, hundreds of days of uptime. Simplicity is a prerequisite for reliability. And we found this to be true. By keeping things really simple, we found that we can build large scalable systems. So let's talk a bit about delivery modes. How badly do I need a message? And so first, what are delivery modes? Delivery mode is just a guarantee of the message being delivered. So at most once is really, it's no guarantee of delivery. Messages can be lost. It's up to your application to realize the message can be lost. It sounds really fragile, but it's not. That's how the internet works today. Just think about your HTTP requests. You don't know if they're going to get there. You time out, you retry. Now, there are cases where you need at least once messaging. So a message will always be delivered, but in some cases, it can be delivered more than once. These cases are pretty rare, where typically you'll have both parts, the client and the server, going on at the same time, come back up. You might get the same message redelivered. But nowadays, most people are designing their applications to be idempotent, so hopefully they'll handle this case. And then there's exactly once, which I argue is unnecessary, especially with the advent of the 12-factor app. But it's also very, very complex, and this complexity really slows things down. So Core NATS provides at most once delivery guarantees. And this is your internet quality of delivery. NAT streaming provides at least once delivery guarantees. So you'll get a message guaranteed to be delivered, but you might get it more than once. NAT streaming. So what is NAT streaming? NAT streaming is a data system powered by NATS. So rather than build this into our core NATS infrastructure, we've layered it on top. So some of the features include at least once delivery. You can replay by time or sequence number. So you can say, give me the last hour's worth of messages on this subject, or give me every message since sequence number 500. There's last value caching. You can use it when you come up as your application. Give me the last message that was received for initialization. You have the concept of durable subscribers, where you'll continue to get the stream of messages, and if communication is interrupted any way, your client goes down, loses connectivity with the server, when it comes back up, it'll pick up exactly where it left off. You've got rate matching per subscriber. I mentioned slow consumers with Core NATS. With NAT streaming, it feeds data, it sends messages to consumers at the rate they can handle. So you might have one consumer receiving messages at 5,000 messages a second, and another one that can process 5 messages a second. NATS will rate limit these for you. We've got memory, file, or database storage, and high availability through fault-tolerant or clustered configurations. This clustering is a little bit different than Core NATS. It sits on top of Core NATS and actually uses Raft. And then we can scale through partitioning, where some NAT streaming servers might handle a subset of subjects, and other NAT streaming servers might handle a different subset of subjects. How do we monitor NATs? Well, each server is monitored independently. And I go back to the very, very simple case. We make things simple. You simply enable a monitoring port and then pull an endpoint for metrics. We have a variety of metrics you can pull. And then the simplicity allows you to build more complex tooling on top. Monitoring information is JSON formatted, very easy to parse. So some of the tooling you can build on top, and Wally here actually wrote NATS Top, which is a great development tool to look at the server and see what's going on. If you've used Top, this should look somewhat familiar. But for the enterprise, we've written a NATS Prometheus exporter that pulls metrics from the NATS server, lets Prometheus aggregate it, and then we use Grafana as a dashboard. Use your favorite dashboard, and you can view NATS metrics like this. What's coming up in the future of NATS? We'll have extended client support for N keys, which would be a utility for public key signatures utilizing ED 25519. We'll have cloud provider integrations. Events that might happen in Google or Amazon will surface into NATS and let you consume those events. We've discussed extensible security, a security plugin so you can plug in your own custom or other common authentication and authorization systems. We're looking at features to connect and bridge clusters of NATS servers to create a NATS deployment at a global scale. And this is big. I know it's big, but we want to be able to provide connectivity between millions, and you got to aim high, billions of clients. Think clusters upon clusters upon clusters of NATS servers that are able to communicate. And then we're going to continue work on integrations with other CNCF projects, including more support for Prometheus and Kubernetes. If you want to contribute, we welcome contributions of all kinds. Some ways include highlighting your NATS usage or insights in the NATS blog. You can fix a bug. You can add, fix, or clarify documentation. It's sometimes embarrassing, the number of typo PRs we get. You can propose or add a feature, and or just present your own NATS project at meetups. We get quite a few of those. So now let me go to I'll do a quick demo and talked about how simple NATS is. And I'll just show you what the protocol looks like. I call this the human NATS client. So I'm going to start a NATS server here. I started it with -d-v, which stands for debug verbose. It's going to print out absolutely everything. And instead of a client I've written, I'm going to use Telnet. I've connected. So I've connected the NATS server. The NATS server has returned some information back with like the server ID, some authorization information, whether or not I need to use TLS, the max payload, things I can use in my client to make my client more resilient. And then I'm also going to Telnet here. So now I've got two clients. This one's going to subscribe. So what I did is I subscribed to a subject called kubecon.nats, and I gave it an ID of 1. The ID is required because you might want to have multiple subscribers on the same subject within an application. And now what I'm going to do down here is I'm going to publish to kubecon nats, and I'm going to say I'm going to publish 5 bytes. There we go. So this is how simple the NATS protocol is, and human NATS client. Wally will be giving the deep dive, where he'll have much more in-depth demos a little bit later on. But at this point, I'd like to open it up for any questions. Yes?
So I have 3 questions.
Okay.
The first one is, when you said the server was distributing the load between the subscribers, which algorithm is using? Like doing a round robin or?
So with core NATS, it's random.
Okay.
With net streaming, it's actually the client that has the least number of outstanding messages. So it's the client that's least busy is the one that gets the new message.
Cool. When you said 18 million messages, of which size is the payload in that case, for example?
I think that was 128 bytes. Okay. I'll have to look.
Cool. And the last question, sorry for
no worries.
It's related. Like, is it compatible with? I saw in the payload you put bytes. So is it compatible with any data serialization formats like Avro, protobuffer?
Anything you want to put in there. And in fact, NATS streaming uses protobuf.
Okay. So
what we do, NATS streaming, is we convert our streaming data into protobufs and then use core NATS, basic NATS, to send it. But NATS is payload agnostic. Anything you want to send in there.
Perfect. Cool. Thank you.
Oh.
I have followed a few conferences regarding service mesh before coming here. I'm kind of surprised to see a middleware. Still, how do you position this compared to a service mesh? Because for me, the service mesh was to take this kind of middleware to cut it into what they call proxy and to put as a sidecar next to each and every piece of software, which makes the whole system self-provisioning instead of auto-provisioning?
That's a good question. Yeah, so we do have some features in NATS that we haven't talked about that we can go into more depth as far as message patterns and stuff that kind of might fall outside of the service mesh. I agree there is some overlap there, but NATS is almost more specialized. If you have different patterns you want to use that don't fall into service mesh, you can use it.
Okay, and second question, and then I'll pass them. Regarding the streaming part, the demonstration I have seen is extremely similar to what Kafka is offering, for instance. How do you differentiate NATS in the streaming part and a Kafka cluster?
Well, first let me say they're very similar in that they are log-based streaming products. So they're similar there. A big differentiator is the NATS streaming clients don't have to keep track of an offset. So that is actually kept inside the server. And that means you can make the clients very, very simple. Operations don't have to worry about where a client left off. They don't have to worry about losing that offset. NATS takes care of that for you.
And regarding the replaying then, do you have feature to replay messages?
We do. So
but server side? I mean,
yeah. Well, I mean, what you do is you create a subscriber, create a new subscriber saying, I want to receive messages. And by the way, start me at the last an hour ago, or start me yesterday at 3 p.m., or just give me the last message.
Thank you.
Sure.
Hi, I've got a quick question. If you have a setup where you have multiple NAT servers with high availability enabled, or some setup, what happens? So is there some resiliency in memory, or do you use the multiple servers to distribute the load in a way that if one goes down, messages are lost?
With core NATs, messages are lost. And that's because we only give the at most once delivery guarantee. And it makes our algorithm to keep state within the servers very, very simple. And we don't actually have to keep exact state in the servers because we don't give that guarantee. In NAT streaming, we do have that at least once guarantee. So NAT streaming uses a different algorithm on top of that uses Raft.
Okay, thanks.
Very short question. Kafka was already mentioned. We're using RabbitMQ right now. So NATS streaming client would be the solution. Can you give good reasons to switch to NATS?
Don't make me compare NATS to Rabbit. Rabbit's more of like a Swiss Army knife, right? It does a whole lot of things. And NATS is very specialized. NATS is specialized and works well, in the cloud, works very well for deployments that need extremely high performance. So what I would invite you to do is compare the both and then let us know what you think. Please write a blog.
Okay. Question. Is there some way maybe with NATS streaming that you can enforce ordering guarantees if you want?
Well, actually, we do have ordering guarantees. So on a single connection, we're source ordered guarantee. So that means you get the same order that messages were published. And that's in core NATS as well as NAT streaming.
Okay, so if the consumer will always get the messages in the order in which they are produced?
Yes. Yeah. Okay. Unless you lose connectivity or something like that, then ordering guarantee is guaranteed in NAT streaming. But in core NATS, it's up to your application then, right? If he might publish a message and not realize it wasn't delivered and publish another one. So it's at that point, it's up to your application to guarantee ordering, unless you're using NAT streaming, which will guarantee ordering.
One more question. What is the language support for NATS for different languages? I know, for example, Kafka has awful support for PHP and Python.
We have PHP, Python, Node, C#, Java, Golang, Rust, Ruby. We have Erlang, right? Yeah, I think I said C#. We have a lot. Node, did I mention Node?
Thanks. I have a pub/sub case, and I wanted to ask about authentication and authorization. So you said to connect, you need to authenticate with some token and password, or username and password, doesn't matter. And you said to reload credentials, you need to reload some configs. That means the server knows, of course, the credentials. Is there API to manage those credentials on the server side?
No, there's no API. You have to either write something to modify the file, or just modify the file yourself, and then trigger a reload. And that's actually why in the future we have the extensible authority would be to allow users to write their own way to do that real time.
Yeah, that was my third question. So this extensible plugin for the authentication is really nice. And so authorizations, what the users can do after they pub or sub, is there any pattern matching? Like if the user A connects, he can only publish to queue called A or something like that?
There is. We have what's called wildcarding.
Yes.
And yeah, and that would probably take quite a while to explain. But basically, if you remember, I did kubecon.nats, right? You can each one of those we consider a token. You can substitute one of those tokens with either a star, which means anything matches that token, or a greater than, which means anything beyond that token. And it's a simple pattern matching, but it will work for if I want a certain subset of subjects for users to be authorized on, you can use wildcarding to do that.
Yeah, thank you.
Sure. I think there was someone in the back corner that's been. I'm sorry?
Any support for headers?
Oh, headers. No header support. That's part of the simplicity part of NATS. I can share, what you can do is look at NATS streaming. And what we did for that was we actually needed headers for NATS streaming. So we used protobufs on top of that to almost build a custom protocol on top of NATS. Does that make sense? Yeah. No. Okay.
Small question. Do you have NATS streaming replication or mirroring when you have multi-cluster deployment?
I'm so sorry, I couldn't hear you.
Do you have replication solution for NATS streaming or mirroring?
Oh, yes. Well, somebody has contributed a mirroring solution for NAT streaming. So, I imagine something along the lines of 2 geographically separated sites, and you want to create a mirror. Actually, I think that was R.I. Paneer, right, who did the NAT streaming mirror. And we actually have a link to that on our website.
Just a quick one. DR, I guess, and archiving of the streamed logs. What's the story there?
So
if I want to say, after 30 days, archive somewhere, and then potentially at some point restore so I can replay from time 0, is there any way to kind of accommodate that?
you can do that. So what happens is exactly that. After a period of time or certain size of messages that have accumulated, the NAT streaming server will trigger either a partition, or they'll either partition the file and take about a quarter of it off and archive it for you, or it can trigger a script where you can do whatever you want with that chunk of file and move it to some long-term storage. So then the streaming server will keep operating. You don't have any manual intervention you necessarily need to do.
And does that happen by topic or for the whole thing?
That's for the whole thing. Yep. Do have time for a quick one if anybody has one. It's almost time. Oh, okay. Any more questions?
In the storage architecture, you've got a choice of two options, SQL and file. Can you add more detail behind that?
What sort of detail were you
So
looking for?
is it a sharding architecture? Are you replicating to two different pods at the same time? How does the resilience work?
Okay, so we've got a couple different stories there. One is we've got a fault-tolerant pair you can set up. One is live, one is warm. When the live one goes down, the warm takes over. It's your responsibility to make sure that that data store, your persistent volume claim there, is backed up. We have we've got full clustering where, and that uses Raft, where you have independent files. So let's say you had 3 of them, you might have 3 different persistent volume claims, and they would all maintain consistency through the Raft protocol over NAT streaming. Sure. We good?
Yeah, you can do another one.
Oh, okay. All right.
Do you have the concept of consumer group?
Do the concept of consumer group.
Do we have a concept of consumer group like in Kafka? Can you go into a bit more detail? Okay. Okay. So, yeah. So it sounds like the load balancer we have is very similar to what you're describing. Thank you. Not at this time. We were planning, maybe sometime early next year, but yeah, we don't have a timeline on that quite yet.
So during the demo, you connected the telnet, and the server was kind of talky about its versions. Was that because the server was running in verbose mode?
Yeah. So the question was, the server was very verbose about what it was displaying. Yes, that's because it was in verbose mode. If I'd turned it off, you wouldn't have seen anything happening. All right, well, come find us. We have t-shirts and swag. Please get your sticker. And thank you very much.